Hello students, welcome to the session. Hope you are all doing good. Today we will discuss about functions and then limits and continuity of those functions, like how to find the limits of the functions, and we'll know what are the types of functions, like which are continuous, which are not continuous and stuff, and we'll solve few problems based on those questions, those concepts. Okay, so basically I am assuming that you all know what exactly is a function. So you know what is a function, right? So exactly to talk about a function, like there is one simple concept, like to identify whether a given equation or an expression is a function or not, is just to graph it. Once you graph it, and then if you draw a line perpendicular to the x-axis, or say a vertical line test, we call this as a vertical line test. So when you graph the function and draw this line, and if it cuts the graph at only one point, then it is a function. There is no doubt that it is a function if it is cutting at only one point. So what if you have an equation of a circle? You know the equation of a circle, right? Like what is the equation of a circle? So x minus a whole square plus y minus b whole square is equal to r square. And then this is not a function, because when you draw a line perpendicular to the x-axis, or say parallel to y-axis, you cut the graph at two different points, and this is not a function, right? So we know this. Then what exactly is a function? When can you say that a function is continuous? Is if you can draw the graph of the function without lifting your pen or pencil, whatever it is. Like if I have a graph like this, then this is not continuous, because there is a break here. I have to lift my pen or pencil to draw the graph. That's why it is not called as a continuous function. So there is a break in it. So there are types of continuities, like asymptotic discontinuous function. Like, see, for example, if I take f of x is equal to 1 by x minus 1, right? So this graph at x is equal to 1, there is a discontinuity, because when x becomes 1, this value of the function will become infinite, because it's not defined at that point. So these type of functions are, you can talk about the integral function, like greatest value functions, or smallest integer functions. These type of functions are also like discontinuous functions, because your graph will be like, these are called as step functions. Sometimes your graph looks like this, like because at every integer there is a break, right? When you are changing from integer to integer, there is a break, because from 1 you have to go to 2, because there is no value between 1 and 2. Because if you take any value of any value less than 2 and greater than 1, its value will be equal to 1. The integer which is greatest integer, which is smaller than the given value, will be considered, right? So these all are discontinuous functions, right? So now we are saying that when f of x is equal to 1 by x minus 1, and this is not continuous at x is equal to 1. So how are we trying to find? So for this we have a concept called as limit of a function. You already have learned this. I'm sure that you all know, well, we are all well aware of this, but just give you a brief of it. So when there is a function and you take a point, say suppose some x is equal to a is the point I'm taking, and see, the limit of the function is like, when I have, say suppose let me take at this point, say suppose at this point the value of the function will be f of a, right? If this graph is called as f of x, then this will be f of a. So when can we say that limit is existing? Is for a function f of x, the limit, you say that when you are reaching from reaching to the graph from the left side, you can reach the point from the right side. Both the ways you can do, right? Like you can travel this way, or you can travel this way, and you can reach the point. So when you are reaching from the left, it is called as the left limit, and is denoted as x tends to a minus f of x, and the right limit is also known as x tends to a plus f of x, right? So these two values should be equal to f of a, the value of the limit at that point, right? So if these exist and they are equal, then it is called as the limit of the function is existing, right? When the limit exists, the left limit is equal to the right limit, which is equal to the limit of the function at that point. right? So we calculate this like, generally we know like x tends to a. Suppose f of x, where f of x is equal to, I say, x cube minus say a is given to me, say suppose, then this will be equal to a cube minus a. So a cube minus a is the value. We generally substitute it into the variable, like the whatever value, the limit value is substituted into the variable, right? So now suppose I have say a function f of x is equal to say x cube minus, let us take a simple example, 3 cube by x minus 3, right? This is given to me, and they said like find limit x tends to 3. So what can we do to find this? Like, when you substitute, it's clearly it's evident, right? Like when you substitute 3 here, this value will be equal to 0 by 0 directly, but that is not a defined form for us. So what generally we do, like whenever you have these type of functions, like when you have limit x tends to a, and when you substitute this, you might get 0 by 0 sometimes, or infinite by infinite sometimes, and something by some number by 0. And these type of situations arise. So these are not the values what we are looking for when you are solving any question related to limits. So what exactly we have to do when you come across these type of scenarios? You have different situations that you can handle, like when these type of situations come to you, either you do some algebraic operations to simplify. For example, here you can use the formula of a cube minus b cube, and you can try to eliminate the part which is making your denominator 0, or maybe which is making your expression undefined. So you use some algebraic operations to do that. That is one thing. Or maybe you have something called as L'Hopital's rule, which is used to simplify these. Like when you have undefined forms, you can differentiate the numerator and denominator given that the two functions are differentiable. What is differentiable again? See, when the function must be first continuous. To be a differentiable function, it must be continuous, and it should be the slope should be, you should be able to find the slope, like the value of the left limit should be equal to the right limit, and it should be equal to the limit at that particular point. Then only we call the function as a differentiable function, right? So when you have the function, both the numerator and the denominator as differentiable functions, then you can use L'Hopital's rule, and you can differentiate both numerator and denominator and reduce those into a defined format, and you can solve those questions. I'll show you how we do them in time now, like when we are doing this, right? So this how to simplify this, like you can use this formula of a cube minus b cube, and you can simplify this value of this limit, right? So sometimes, okay, before going ahead, let me see if I have something like limit x tends to infinity. I have 2x plus 5 by say I have 3x minus 2. This is a function I have, right? So how do I find the limit of this function, like this rational function, you can say? When you substitute x is equal to infinity, your value is again undefined, right? You cannot get that form. So again, can you do any algebraic simplification here? No, but you can use L'Hopital's rule here to simplify, and you can do it. Or if we are not completely good in differentiation at times, like this can be done without using L'Hopital's rule also, like without differentiating numerator and denominator, by simply dividing both numerator and denominator with the highest quotient of the variable. Like here and here I can divide it with x, and here also I can divide with x. Then limit x tends to infinity, it becomes 2 plus 5 by x, means I'm dividing the entire thing, okay, not the last term, and then 3 minus 2 by x. So why I am doing this, like when x tends to infinity, we all know 1 by x tends to infinity 0, right? Like because it is nothing but the fraction with the denominator, the large denominator, the biggest denominator, which becomes 0. right? So then 2 plus 5 by x by 3 minus 2 by x, then this value will be simply 2 by 3, because this is going to get a value of 0 when 5 by x and 2 by x will be equal to 0, right? So this is how you do when there is infinity or something in your questions. You can do this way, like you can divide with if it is an algebraic expression, right? Now most of you might have come across this, like limit x tends to a, say x power n minus a power n by x minus a. Yeah, immediately most of you might be saying it is n into a power n minus 1. So how many of you can simplify it or solve it is, I'm not so sure, but don't worry, I'm not going to solve it for you now, but just I'll let you know in brief like how you can do this. Like you can use an algebraic rule, or maybe this is equivalent to when I say x tends to a, I can simply say x minus a tends to 0, right? Like if x tends to a, x minus a will be 0, right? So then I can write this as x minus a whole power n minus a power n by x minus a minus a. Or simply, this value you can treat it as a small value h or something like that. Then limit, you can simply write this as a plus h whole power n minus a power n by a plus h minus a, where h tends to 0. See, if I'm taking h to 0, what am I getting? I'm substituting a in the place of x. Other than that, I'm not doing anything else, right? So you can use this, and you can apply the binomial rule, binomials expansion. Then what happens? Your a power n and a power n gets cancelled. You get a and a gets cancelled here, and in the expansion above you can take h common, and you can cut that h. See that this is the main obstacle for us, like this h in the denominator, because that is making it 0. As see, we are already removing a and a here by cancelling out those positive and negative a's. By cancelling those out, h is still there, but that h is also again going to 0. So you can take h common and cancel, and you simply end up with n times a power n minus 1 when you simplify those things, right? This is one rule which you are going to remember when you are trying to solve questions, because we might use this in our next coming problems. Okay, then we need to remember or know, like you might have already learned this. I'm not going to prove all of them for you now, but I list down some formulas which we are going to use in our coming questions, which will help us in solving those questions. Okay, the first one is limit x tends to 0, sine x by x is equal to 1. Even the reciprocal is also 1, right? Like that is limit x tends to 0, x by sine x, this also will be equal to 1. Then limit x tends to 0, say tan x by x is also equal to 1, vice versa, like the reciprocal is also the same, right? Then what we are going to use is say limit x tends to 0, log 1 plus x by x is equal to 1. This comes with the the expansion of log 1 plus x, and then you can cancel that x, and you will just be left with an expression which has 1 and some x terms in the expansion, and those will become 0 because x tends to 0 there. And so this is one more we are going to use. And then say limit x tends to 0, we might use this also, 1 plus x whole power n minus 1 by x. This will be simply equal to n. This is again the same rule like the binomial expansion. If you use and simplify, you will end up with this. And also we might use limit x tends to 0, e power x minus 1 by x. This value will also be equal to 1. This is nothing but the expansion of e power x we'll use, and then you get those things cancelled, and just you will be left with 1. And limit x tends to 0, we can use a power x minus 1 by x. This will be equal to log a base e. This value, this is like applying logarithms on both sides, and you can solve it easily. And I think these would be fine. Like we can use these and solve questions. So you need to remember these formulas when we are using this limits. Maybe limit extends to 0, a power x minus b power x by x. Yeah, this rule also we might use, which is log a by b base e. So these are the formulae which we might be using in solving our questions, like whatever come on in exam, right, for the limits. So remember these, like these are the rules which you use, right? Sine and then the tan, these two are the same. It's easy to remember. Sine x by x is equal to 1, and the reciprocal tan by x is also equal to 1. Then the logarithmic part, 1 plus x by x, which is 1. This one is simple, by binomial expansion we do, and this one is exponential expansion. You substitute and you get it actually. So this is a formula which you need to remember. And if it is in a powers, then it is log a base e, which you solve by using, taking logs on both sides. You take this function as something and apply logs on both sides and solve it. And this one, if see here, the difference between these two is like this is a power x minus 1, this is b power x is there. So what you exactly do is like divide by b power x, you get a by b whole power x minus 1 by x, and so the same thing comes here. It's nothing different from it, but we might use it. Got it? Okay. Now let us quickly solve some problems, based on these which we have discussed, based on the rules which we have discussed. So the first question is, limit n tends to infinity, like 3n square minus n by 9n cube minus 1, where you have n tends to infinity. Like we already know like what happens when n tends to infinity, right? Like you have to divide by a highest coefficient of both numerator and denominator. So this will be limit n tends to infinity. I can divide the numerator by n cube and the denominator by n cube, right? So see here, this n cube is outside the square root. So in this case, to take it inside the square root, then only you can divide, right? Like if you do this way, you're not going to come anywhere close to it. So what I am doing is, to take it inside, I have to square, right? This is square and this is also square, then it can go inside the square root. So then what will happen? Limit n tends to infinity, I get 3n square by n power 6 minus n by n power 6 by square root of 9n cube by n cube. Now I have taken it inside the square root, minus 1 by n cube. So now this will be nothing but limit n tends to infinity. This is 3 by something like n power 4 minus 1 by n power 5. This doesn't matter now for us because this is going to be 0 anyways. Now this will be square root of 9 minus 1 by n cube. Now n tends to infinity, we already know that 1 by n then should go to 0. So when I put this, the numerator for me becomes 0 minus 0 by root of 9 minus 0, which is 0. So the answer for this is simply 0. Generally you can say, like when the the power of the denominator, the variable in the denominator is more than the numerator, then it is obviously going to be 0, right? Did we get it wrong somewhere, guys? See here, like n cube square root, I have n cube outside, I want to take it into the square root, so it should be inside the square root, it should be n power 6, right? If I'm not wrong, correct? Right, guys. Just give me a second, I'll resolve this question. 1 second. I don't know how many of you have identified this. Right? So see, this is n cube. So what exactly we can do is limit n tends to infinity. Instead of doing this 3n square minus n by this n cube coming out of the square root should be like, you know, I want to make this as square root of 9 minus 1 by n cube. One second, guys. So if you take n into n cube, right? So this n cube should be coming out, then it becomes n tends to infinity 3n square minus n by n power 3 by 2 times root of 9 minus 1 by n cube. This is what it is. Now this is a good question actually. Like here the power of the denominator is actually smaller than the power of the numerator. So there is no way that we are going to get a defined limit for this one. The limit for this question is should be infinity. For example, like, you know, if I divide this with n square, then limit n tends to infinity 3 minus n by 3 minus 1 by n by this will be, if I divide with n square, it is n power 3 by 2 minus 2 times 9 minus 1 by n cube. So this would be equal to limit n tends to infinity 3 minus 1 by n by n power minus 1 by 2, right, times root of 9 minus 1 by n cube. Limit n tends to infinity 3 minus 1 by n by 1 by root n times root of 9 minus 1 by n cube. So now this is a denominator's denominator again. So what happens? N tends to infinity, it goes to the numerator, times 3 minus 1 by n by root of 9 minus 1 by n cube. So now see, you did not get rid of this n here by doing whatever it is. Like, even though if you substitute n is equal to infinity, this might be 0, but this is still infinity. So this is in the form of infinite by something. So the limit of this is not defined. Okay. So this is you can ignore this one, guys. Now the second one is limit x tends to 0 x cube cot x by 1 minus cos x. So how do we do this one? This is, you know, I think by looking at it you might be thinking like, okay, you can use some trigonometric identities to solve it. So let us try. Limit x tends to 0 x cube cot x can be written as cos x by sin x by 1 minus cos x times I multiply it with 1 plus cos x by 1 plus cos x, right? And this is equal to limit x tends to 0. This will be x cube times cos x times 1 plus cos x by, now 1 minus cos times 1 plus cos is 1 minus cos square x times this sin x, right? Okay, so this can be written as limit x tends to 0. See, why we did this is like I want to get it into the form of, you know, like x by cos x or x by sin x or sin x by x, something like that, so that I can make the limit as 1, right? So for that purpose we are doing this. So it will be x cube by this value can be written as sin square x, right? Sin square x into sin x times limit x tends to 0 cos x times, see, I can write this x limit multiplied to all the functions separately, right? I am writing it to all of them. Now then this will become limit x tends to 0, this is x by sin x whole cube. See, I am making it into whole cube so that I know we already discussed it, right? Like limit x tends to 0, x by sin x is equal to 1. So I can apply that principle here, times limit x tends to 0 cos x times limit x tends to 0 1 plus cos x. So this value will be equal to, this is 1 times this is also 1 because cos 0 is 1 times this is 1 plus 1 because 1 is here and cos x cos 0 is 1, so it is 1, which is equal to 2. So the limit of this is equal to 2, right? So this one we just use trigonometric identities. Next, see, limit x tends to a f of x times f of a minus a times f of x by x minus a. What is the value of this is what he's asking, but he gave that f dash x exists at a, means it is differentiable at a. So what is f dash x? Is nothing but f of x minus f of a by x minus a, right? So that's what we can say. This is the differentiation, like it's nothing but h tends to 0 f of x plus h minus f of a by x plus h minus a. So that's the same thing we are using here, the definition of differentiation. Now I want this value, limit x tends to a x times f of a minus a times f of x by x minus a. So what I will do is I will add a times f of a and subtract a times f of a. Why we are doing this? Now what we can do is, like, I can write x times f of a minus a times f of a by x minus a, means this term here and this term here is one I'm grouping, and then minus limit x tends to a, I'm separating the limit here, I took minus common out, so this will become positive, a times f of x minus a times f of a by x minus a, correct? Right, now what can we do here? I can take f of a as common, then I have x minus a by x minus a minus limit x tends to a, if I take a common, it is f of x minus f of a by x minus a. So this will be cancelled here, and x tends to, you cannot substitute anything there, so it is simply f of a minus this a is a constant, so which you can write out of the limit, times limit x tends to a f of x minus f of a by x minus a. This is nothing but f dash a, right? Means f of the differentiation at a, so this should be f dash a. So f dash a. So the value of this at x tends to a is f of a minus a times f dash a. That is the limit of this function, right? Next, limit x tends to 0 e power sin x minus 1 by x. So how do we do this one? Let us see. So what are the formulas regarding this? We know we can use, see, sine has come here, so we can use limit x tends to 0. This is x tends to 0, right? Sin x by x is equal to 0 is the one formula we can use. And then limit x tends to 0, e power x minus 1 by x is also equal to 1. So this is 1, I'm sorry. So 1 and 1, these are the two formulas we can use. So we have to get this into that form. The variable here for me is sin x, so I need sin x in the denominator. So what will I do is I divide with sin x. If I divide with sin x, I should multiply with sin x at the same time so that I don't change the function. So this can be written as limit x tends to 0 e power sin x minus 1 by sin x times sin x by x, right? There is no change in the actual value of the function. Now what can we do? Limit x tends to 0. We can write the limit for the two things, right? This is a basic rule, you know, right? F of x into g of x. When limit is applied, you write limit f of x into limit g of x. So that's what we are going to do here. Limit e power sine x minus 1 by sine x times limit x tends to 0 sine x by x. So then this value is 1 for us, because e power x minus x. See, in the place of, okay, one thing here, this is x tends to 0. When x tends to 0, what will be the value of sine x? Sine 0 is 0. So you can simply write sine x tends to 0. There is no problem in doing that, because when x is tending to, you are not changing the actual limit of that, like you are actually applying a function onto it, right? When x tends to 0, sine x also will tend to 0. So then when limit x tends to 0, e power x minus 1 by x is what we need. So I'm writing limit sine x tends to 0 e power sine x minus 1 by sine x. This also will tend to 1, because when x tends to 0, sine x also tends to 0. So this is a key point to be remembered here, right? 1 times, and this value is again 1. So final limit of this is 1, right? The next one is limit x tends to 1 tan x square minus 1 by x minus 1. Okay, let us try doing this. So here we will use the L'Hopital's rule. Like, see, when you substitute x is equal to 1, 1 minus 1 is tan 0 is 0, and x minus 1 is 0. So our this one is coming in the form of 0 by 0. Right? So then, and also x minus 1 is a linear function which is continuous line. A line is always a continuous function and it is always differentiable, and tan is a function which is always differentiable, we know. So you can differentiate this both in numerator and denominator and try finding its value. Let us try doing it. Limit x tends to 0. Differentiation of this. Differentiation of tan is secant square x, so x square minus 1, secant square x square minus 1, the x square, this is a composite function inside, times, you have to differentiate x square minus 1, so differentiation of x square is 2x, 1 is 0 anyways, by differentiation of this will be equal to minus 1. Now the denominator is not 0, so we are out of the danger zone. Let us substitute the value of x is equal to 0 here. Then sorry, I mean it's 1, right? I'm sorry. So 1, when you substitute, this will be equal to secant square 0 times 2 times 0, right? Right. So oh, I'm sorry, this is 1, x is 1, right? So secant square 0 is 1 times 2 times 1 is 2 by, this is plus 1, guys. X minus 1's differentiation is 1 minus 0, which is 1, I'm sorry, so that should be plus 1. Right, so this is equal to 2 is the limit of this one. This is 2. The differentiation of x minus 1 is equal to 1. I want to see your comments after this video, like how many of you have pointed that this is plus 1 not minus 1. I'll check through it, but fine. So this is 2 here, right? Okay, next one is x tends to 0, 2 times sine 4x times cos 2x by 2 sine x cos 4x. Let us see how we will do this one now. Limit x tends to 0. So immediately we can cancel 2 and 2, right? So that's one headache out. So sine 4x into cos 2x by sine x cos 4x. But see, we know only this is what is our savior for now. Like limit x tends to 0, this value should be 1, so you have to check for that. So limit x tends to 0, I write this as sine 4x by 4x, okay, times x by sine x. When I do this, I can cancel x and x, right? But this 4 is additional for me, so I write this 4 here, times cos 2x by cos 4x. This is all we can write for now. So I bring this 4 out from this limit, and limit x tends to 0. I can write it as sine 4x by 4x times, again, like x tends to 0, then 4x should tend to 0. Limit x tends to 0, x by sine x times limit x tends to 0, cos 2x by cos 4x. This is 4 times this value is 1 times this value is 1 times this value. Cos 0 is 1 and this is 1, so 1. So 4 times 1 times 1 times 1 is 4 is the limit of this function. Right? This is 4. Clear? Next one, limit x tends to 0, x cos x minus sin x by x square sin x is a function which we have to differentiate. Find a limit. Okay. Can we cancel anything here straight away? No. And then when you put x is equal to 0, this is 0 minus 0 by 0. This is 0 by 0 form. So let us take Mr. LH help to solve it. So let us differentiate this, guys. Like limit x tends to 0. If I differentiate this UV rule, if you apply a differentiation of x is 1, so cos x u dash v, okay, whatever it is, cos x plus. Now I am leaving x and differentiating cos x. So cos x ka differentiation is sin x minus sin x. X times minus sin x and minus sin x differentiation is cos x, right? By differentiation of this is 2x times sin x plus x square cos x. Okay, so this will be limit x tends to 0. We can cancel this cos on cos, minus x sin x by 2x sin x plus x square cos x. So here again we can take x common and cancel. So let us get rid of that first. So minus sin x by 2 sin x plus x cos x. Cool. Now if we put x tends to 0, this is again 0 and this is also 0 again. Like when you put x is 0 here, you're getting 0. So now you can take L'Hopital's help again, like you can differentiate it, like not one time, not two times, you can differentiate until you get a determined form. So let me try and do that again. Limit x tends to 0. I'm differentiating this, so sin x ka differentiation is cos x, but there's a minus sign, so minus cos x by, I differentiate this, 2 cos x plus. Now x ka differentiation is 1, so cos x, and cos x ka differentiation is minus sin x, so minus x sin x. So this is after differentiating it for the second time, right? So we differentiated this for 2 times now. Now if we substitute x is equal to 0, this is minus 1, this is 2, this is 1, and this one is 0, right? Right, let's substitute this. So this will be minus 1 by 2 plus 1 minus 0, which is equal to minus 1 by 3 is the limit of this function. This is minus 1 by 3, right? After substituting x is equal to 0 into that function. So that's all from my end now. I think you have understood. Let me see if you have any questions. We'll try to address them. Okay, I don't see any questions. So keep practicing on these limits. There will be a lot of confusing questions in this, and you have to pay attention to your signs like minus and plus wherever you are putting them in. When there is a lot of scope that you misplace those signs and lose your marks. So pay attention to those things. Anyways, we'll discuss more on tips and tricks in solving these questions before your exams. Maybe I'll meet you up in one more session with those things. Till then, signing off, Satish.